In this video, I want to briefly talk about the basic structure of something called a polynomial. So a polynomial is just some expression written as a sub n times x to the n plus a sub n minus 1, x to the n minus 1 plus a sub n minus 2 times x to the n minus 2, and you go on, plus a sub 1 times x plus a sub 0. Okay? And these little n minus 1, n minus 2 that are in the lower script on the a's here, these are just what we call indexes. Okay? That just means it's the variable that we assign to it's just the coefficient we assign to the variable raised to that power. Okay? These can all be different numbers. It doesn't mean you're doing anything to a, it just means that's the variable assigned, or the coefficient assigned to the variable with that exponent. Okay? The coefficient of any polynomial, right? A coefficient in a polynomial is the number multiplying a variable. Okay, so in this case, a sub n is going to be a coefficient. A sub n minus 1 is going to be another coefficient. A n minus 2 is going to be another coefficient, and so on and so on. Okay, and the leading coefficient is the coefficient of the leading term in a polynomial written in standard form. So what we have here is a polynomial written in standard form. And you can also describe it as being written in descending order, okay? So here you have n, then to n minus 1, then to n minus 2, all the way down, where you have each of the terms is written in order from largest to smallest in terms of their exponent, okay? And the degree is the exponent of the leading term. Okay, now this may also all feel very abstract, but I promise you this really isn't all that bad. Let's just see if we can apply this to 2 or 3 examples and see if we can make sense of all of this abstract language here. Okay, so if we want to find the degree and the leading coefficient, say of this polynomial, 15u minus 2u to the fourth minus 8u to the third, the first thing we need to do is we need to write it in standard form, just like this. Okay, that's it. And all that we're really saying here is that means that we're going to start with the largest degree term. So here we have the largest term here, the largest exponent term is negative 2u to the fourth. So we're going to rewrite this as negative 2u to the fourth. Okay, and then we're going to see if we can find the next smallest exponent term. So then we have negative 8u to the third. We don't have anything squared, but we do have 15u, so plus 15u. And we don't have any constant term out front. Okay, so all we did was we rearranged this polynomial in descending order, where we started with the largest exponent and we ended with the smallest exponent. That's all we did here. Okay, so the degree of this polynomial is going to be the exponent on the leading term out here, this first term. Okay, so our degree here is going to be 4, and our leading coefficient is the number that we're going to multiply this variable by. So we're multiplying u to the fourth by. So our leading coefficient is going to be negative 2. That comes from here. Okay, how about this one? Here we have v to the seventh minus 10v minus 6v squared. Okay, well, we need to rewrite this in descending order or in standard form. So we already have the largest exponent term out front. Okay, so we're going to leave that where it is. That's v to the seventh. Okay, then we're going to find the next largest exponent term. That's going to be negative 6v squared. Okay, so we're really paying attention to these exponents here. So we'll have minus 6v squared, and then we'll have minus 10v. And again, the degree is the number that is the exponent of your leading term. So this is going to be 7. And the leading coefficient is the number we multiply v to the seventh by. And in this case, that's 1. Okay, so we can think of an implied 1 here. Okay, anytime you don't see a coefficient next to it, you can just assume the leading coefficient is 1. Okay, how about this one? X to the fourth plus 3x squared plus x to the 13th plus 1. Well, x to the 13th is obviously the largest, so we're going to start with that. So that's x to the 13th. Okay, and then therefore we already know that the degree is going to be 13, right? Because that's our largest degree term. Okay, but then we have x to the fourth, then we have 3x squared and then we have 1. And again, in this case, our leading coefficient is going to be 1. Okay, and this is all gonna like this all may seem very kind of out of the blue, but all of these things are going to be helpful for trying to solve more specific problems later on. So it's good that you know what the degree of a polynomial means, and it's good that you know what the leading coefficient is, because each of these are going to carry meaning with them as we try to solve more complicated problems.